would actually happen to our planet and to us if it all just stopped?
Welcome to today's Explainer, where we're going on a seriously fascinating journey into the hidden forces of a spinning Earth. By looking at what happens if the planet hits the brakes, we'll uncover the invisible forces that silently run our world every single day. Let's dive in.
Section 1. The sudden, catastrophic stop.
So the immediate horrors here are, well, they're almost unimaginable, because physics tells us that an instant stop wouldn't exactly be a gentle deceleration. If the solid ground suddenly locked into place, the atmosphere absolutely wouldn't. The air would just keep racing east at over 1,600 kilometers per hour. We're talking supersonic winds capable of literally stripping the surface down to bedrock. At the exact same time, the oceans, which hold on to all that massive momentum, would surge eastward, creating global mega tsunamis far worse than anything in recorded history. Basically, if it's not anchored deep into the Earth's crust, it's getting launched sideways.
Now, even if the Earth didn't stop in a split second, say it braked to a halt over the course of a minute, you would still experience a massive sideways deceleration. We're talking about 3/4 of Earth's normal gravity pushing you sideways. To your inner ear, down wouldn't feel like it was beneath your feet anymore. Actually, scratch that, it would feel like down shifted to a crazy 38-degree angle. That sudden, extreme shift in the vector of gravity, that alone is easily enough to topple most buildings across the globe.
All right, Section 2. Gravity and the new oceans. Let's take a look at the math comparing gravity at the poles versus the equator. Right now, gravity is at its absolute maximum at the poles, but down at the equator, it's slightly reduced. But if the Earth stops spinning, the gravity at the equator actually increases by about 0.034 meters per second squared. To put that simply, you would literally feel heavier standing at the equator on a still Earth.
And the culprit behind this is an invisible entity called centrifugal force. As the Earth spins, it creates this outward push that slightly counteracts the inward pull of gravity. You know, it's the exact same force that squishes you against the door when your car takes a really sharp turn. Over billions of years, this outward push has actually caused the Earth to bulge right at the equator. So our planet is kind of slightly squashed at the poles and wider around its middle.
So what exactly happens when you turn off that centrifugal force? While the water that was being pushed up into that equatorial bulge suddenly just falls back toward the poles, where gravity is the strongest. The oceans would literally drop by 8 kilometers at the equator. This creates a terrifying geographic redistribution. Everything north of Spain, along with all of Antarctica, completely drowns under massive new polar oceans. Meanwhile, the equator is left as the single, barren, massive supercontinent wrapping right around the globe.
Moving on to Section 3, the death of weather. On a normal spinning Earth, we have something called the Coriolis effect. This makes moving air curve, creating those really complex atmospheric cells that distribute heat and moisture. It's the exact thing that gives hurricanes their signature spiral. But on a still Earth, the Coriolis effect completely vanishes. We're left with totally sterile straight-line weather. Hot air rises at the equator, travels in a completely straight line to the poles, sinks, and flows straight back. There are no swirling storms, no jet streams, none of those complex weather systems we rely on. Just constant, brutal loops.
And it gets worse, because without that 24-hour spin, a single day lasts as long as a year. The planet becomes sun-synchronous, kind of like how our moon is tidally locked to us. Everywhere gets 6 continuous months of relentless daylight, boiling away rivers and baking the sun-facing side to well over 100 degrees Celsius. And the night side, that gets 6 months of absolute freezing darkness. The only potential place for anything to survive would be a narrow, violently windy terminator zone, basically a perpetual twilight strip caught between extremes of fire and ice.
Section 4. Deep Earth and Dead Shields.
If you notice the arrows here indicating the direction of the tectonic plates, research actually reveals a westerly directed flow. This means that as Earth rotates eastward, tidal drag from the moon essentially causes the planet's outer shell to lag behind, sort of pushing it west. This massive shear force is what fuels earthquakes, builds asymmetrical mountain ranges, and drives plate tectonics in the first place. See that red dashed line on this cross-section? That marks the low-velocity zone. You could think of this as a massive geological slip and slide. Our spinning planet is quite literally slipping inside its own skin at this boundary. It's a mechanical process that is intimately tied to the Earth's daily rotation.
And if we go even deeper, right down into the outer core, we have swirling liquid iron and nickel. Earth's rotation forces this molten metal to swirl, creating electric currents that generate our magnetic field. We call this process the geodynamo. If the spin stops, the geodynamo dies. Our magnetic shield completely collapses.
And without it, the solar wind, which is a stream of highly charged particles from the sun, would slam directly into our atmosphere. Eventually, it would strip it away completely, leaving us as barren and irradiated as Mars.
Section 5. A technologically broken world.
So, what about our modern civilization? Well, within hours, GPS would become utterly useless. Satellites orbiting Earth have to constantly run this microscopic SAGNet correction. Why? Because the receiver in your phone is moving with the Earth's rotation while the satellite signal travels down to it. Without spin, uncorrected GPS would drift by 10 kilometers a day. Within days, the collapse of our magnetic field would expose our power grids and communication networks to direct, catastrophic space weather. And looking long-term, space agencies like NASA would lose the free 1,670 km/h speed boost that launching rockets from the equator currently provides. That completely alters the physics and the fuel requirements of space travel.
Now, here is a crazy reality check. Earth's spin isn't even perfectly static right now. It's actually shifting as we speak. In 2024, scientists discovered the solid inner core had slowed down relative to the surface. By 2025, seismic data revealed the core had actually deformed in shape. Even climate change plays a role. As polar ice melts and that water flows toward the equator, the redistribution of mass is literally slowing the planet down and lengthening our days by milliseconds.
The quote here really hits the nail on the head. The ground you stand on, the air you breathe, and the molten iron deep below are all part of the same spinning system that has supported life for billions of years. Ultimately, every system is linked. Changes deep in the core affect the magnetic field. The magnetic field protects the atmosphere. The atmosphere dictates climate. Climate moves mass around, and moving that mass affects the spin. It's just one beautifully integrated dynamic machine.
We never really think about the spin, mostly because we've never lived a single second without it. But it builds our continents, protects us from radiation, steers our weather, and quite literally keeps our whole world in balance. So my question to you is, as you go about your perfectly calibrated 24-hour day today, how will you appreciate the spectacular invisible 1,670 km/h journey you are on right now? Thanks for joining today's Explainer.